I hope everybody's fine with me recording.
Yeah.
Okay, great. So, Farah, over to you. Take us through what we have today. I passed out all the general information. If you haven't registered for the event, try and register. We'll keep you posted on if you have to pay out of pocket or we get consent from the school. And please try and practice whatever you learn here on the platform. So those are the informations I have. Over to you, Farah, to take us through what we have for today.
Let me just share the slides.
Sorry.
I think it'll be just easier to share the whole screen, then I can afterwards just, yeah. Okay. Bear with me, please. I think it's just being a bit slow.
You can see your screen.
Can you hear properly? I think the share button froze from my side.
You can see your screen.
We can see your screen.
You can see?
Yes, we can see your screen. So you maybe just minimize the Teams. Yes, great. Yeah. Minimize this as well. The Teams weekly meeting. Yeah, you can minimize that, and then I think.
So can you see that here?
Yes, great. We can see you
now.
Nice.
Thank you for letting me know. Right, so today we'll be taking you through me and Temitope through visualization and the modeling part. So again, just referring this to the roadmap again, like last week you've learned about how to clean and prepare your data set. So this week you'll be learning about analysis in terms of visualization and modeling as well. So right, this is again the same Chris model that we're referring to. Right, this is just referring to the dataset links that we use. So just quickly explain why there's different data. Basically, there's two different visualize as there's I tried to cover visualizations, and then the notebook's just under, and then the modeling notebook, which also includes within it the dataset in case you afterwards wonder the dataset modeling notebook. It's within it. Always access afterwards. I think let me just do slideshow because it's not really nice like that. If that doesn't freeze on me, right? Yes, summary. So just before we even go with building model afterwards, there's one thing I definitely want to clarify it before we build data and to basically understand it a bit more. Visual analysis and the stages or steps for visual analysis include downloading the right packages. Some of you might have heard of them, like such as matplotlib and Seaborn, what they use for and how, and then ensuring that your data set is clean. So, which you have learned in the previous recording of last week. So please practice that, as this is an important part of visualization. Yes, as clean data set will lead to better visualization, meaning better analysis of, and then choosing the plot based on visual analysis to conduct and your data. So if you know what kind of data you're dealing with, you should be able to then know, oh, because that's that kind of data, then that's the kind of plot. All right. Yes, and because I just mentioned the type of data, I'd just like to quickly touch up on this. So at least it makes a bit more sense. You're going ahead and when you see the data as well. All right, so the main two types of categorical data are ordinal and nominal. So ordinal is data is like data that has and maintains an order, so it just keeps going but within an order. And nominal data is data that have basically the categories have no order ranking, so it could be mixed up numbers. There's no specific order going forward. And you have also binary, yes. So that's, for example, binary when you have variables is when you deal with two categories, for example, 1 or 2, or something referring to 1 or something referring to 2, or to a simpler example, such as yes. So when you're trying to find out whether something is yes or no, your output is yes or no. And then you also have interval data. That is data that, for example, is measured on, like I mentioned here, numerical scale that can be measured basically, and it has equal intervals between the values. For example, to make that a bit simpler to understand, you have here temperature, like you have your thermometer or something and your different temperatures. Well, you can see 90 degrees, 80 degrees, 70 degrees. So basically you have different intervals, but they of equal value. And this here, knowing this now should help you going ahead with visualization. It'll make more sense through the codes and everything. Yes, the libraries that I mentioned, downloading the right libraries so you can pull out the right visualizations. So first one, matplotlib, which is used to basically produce graphs and plots, whether it's line charts, scatter plots, bar charts, and so on. And then you have Seaborn, which, if I'm right, is more just to make, like as written here, to draw attractive statistical graphics, so to make your graphs a bit more visually a bit more attractive and appealing. But really, until you have the right graphs that show the right, really that you have graphs that show exactly what you want to show, then the visual is just a secondary part. And then plots, yes, used to visualize a single variable, because you have basically when you're dealing with data, you may want to do different things, such as visualize just one variable, or visualize two variables, or visualize multiple variables. So based on that and the type of data that you have, you can then choose which plot is right for the situation and for the data that you have. Tell me if I'm going too fast or anything. First of all, you have bar charts. So these bar charts are actually good to map categories to numbers. For example, age, you might, like categories such as age or gender or something. You might want to map that to numbers, or even sales or whatever that it is, categories. Yes. So yes, so as written here, nominal, yes, and then small ordinal categorical data, again referring to the previous slides. And then you have line charts, which are good to map your ordinal to interval data. And again, as we've seen earlier, ordinal being data that has an order, going forward has an order, basically 10, 15, 20, like if I'm right, 10, 15, 20, 25, 30, so like the difference being 5 in between, and interval data that has equal values. These are just examples, but when I'll take you through the codes, what I'm saying now will make more sense, so bear with me. And then you have area charts, which are good to map ordinal to interval data. Again, similar to line charts, the only difference is that if you want basically to color the whole area, so it's not just a line with a curve or something, then you can just use an area chart, similar to line chart. And then histogram, yes, which are good to map intervals to frequencies, yes. And intervals data that has equal differences, for example, temperatures, to frequencies. Okay. Yes. And then you have plots that you can use to when you want to visualize two variables against each other. So now, for example, you might want to visualize, it could be even sales against gender, or not gender, but like sales against weather, or whatever that may be. So like plots for two variables. You have scatter plots, which are good to check for correlation. For example, you want to see whether there's some sort of correlation or relationship between two variables that variables that you have. Yes, and it's best to use when you have less data points. And one thing with scatter plot that is good is that if you have too many data points, for your scatter plot to not get messy, you can downsize that, downsample that. I'll show you that in the course ahead. Then you have hex plot. And if I'm right, yeah, hexagon. Yeah, but hex plot, basically, the difference between scatter plots and hex plot is interesting because with scatter plots, you might have just too many points and end up having just too many points scattered across your scatter plot. But with hex plot, what it actually does that you have like small hex, like again, it's used to check correlations, but it's best when you have many data points because it puts them data points within hexagons, so no data point overlaps each other, if that makes sense. And I'll show you how and why that's used. And then you have stacked bar chart, which I use when you want to basically compare like total values or compare sums of values of all your variables, like, you know, how sales, you want to find out about sales, you want to find out about waste, you want to find out about similar things within sales, waste, or and compare them. And then bivariate line chart. Yes, let me just see what's that written. To compare different variable scores. Right. From an example of a time I used bivariate line chart, I'm just trying to find a way to explain it. Yes? I thought you said something. All right. So once I used that in the past to basically compare how for example, compare variables such as sales, waste, and there were other things just not coming back to my mind, but basically you have many variables again that you want to compare between each other and the schools. Right. The interesting part, because I felt like what I was saying, I was mainly saying it, but you will learn more when I take you through the course, I think. Yes. So Google Colab time. Let me just come off this and go on. The interesting part that I was myself waiting to get to. That's just a bit slow, I think. Just check. Ah, there it is. Right. Again, the codes and the note, how to access the notebooks are on the slides. So you can always afterwards check that to get back to the data set and the notebooks. Right. So this is the first notebook, which shows you most of the plots and charts and visualizations. And for example, again, yes, the best one with this, again, as I mentioned earlier, you have to download the right packages, right? So you can then plot your graphs or charts and then apply like some nice styling to make it just more attractive. So again, you have this the usual pandas and numpy that you've learned in last week's lecture. Sorry, just habit from my own lectures that I attend. I use this word, but from last week's session, yeah. But the most important here for you are importing the matplotlib and Seaborn packages. So I'll just run this. That's what you would do as well. And in this instance, I didn't download a CSV or something like that. What I've actually done is I've mounted my drive because my file was actually saved in my drive. So when you want to mount a file from your drive, one thing that you need to do is, you see this code here that I'm just running now, so you can tell which it is. You need to paste that and like from Google Colab, import drive, and from the drive mount the content. Basically, that's what it means. So it pulls. Let me just see. Drive already mounted. Yes, so that worked. But usually when you click this, there's a box that comes up, and because I've already mounted it, it didn't come up. But you just have to click yes, sign in, and again click yes. Right, so when you've done that, that means you mounted your drive, and then from your drive, the line under that you see, you can download basically your file, and that's the code that would, for example, you would use. What I've done here is I've decided to label my data set as wine reviews. So that way, going forward, I know that wine reviews is my, how do we say, data set. And then after the equal, I've put the PD referring to the pandas package. Using the pandas package, read me this CSV file. That's going to pull and read, basically load the data set within the notebook. And then to check that you actually managed, one thing you can do is put your dataset name, dataset name, for example, what I've called it mine, wine reviews, and then put head, for example, and 4. So that will show you the first 4 rows of your dataset. And you can just use that to check that basically you managed to load successfully your dataset. Right. And then when that is done, right, then you manage to get your packages, the right packages, you manage to mount your drive, you manage to load your dataset. So now the visualization. Now let's see how to visualize plots using if you just want to view one specific variable. So here, I want to use a bar chart because I want to find out in which province, basically produces more wine than others. So here, what I've done is, the way the command works, basically in this case is, I've mentioned wine reviews, which is my dataset name. So from the wine reviews dataset, pull me the province variable or column and apply to that the value counts function and the head function and plot a bar chart. I hope me saying it this way makes a bit more sense, because in the past when working when I had a placement in a company, I was literally told you need to make those codes. It's not just code. You have to, Python is similar, it has its own meaning, but you have to give it a meaning. So obviously your data set, the column name, the functions you want to apply to it, and then at the end what you want to plot. So give it a structure so it makes more sense to you in the future when you want to use this kind of functions. So basically from here, what you can see that in California, more wine is produced compared to other provinces. All right. If that didn't freeze on me, keep going ahead. Right. Then you have bar charts. Yes, which are used for that keeps, and data set that just keeps going. So then, for example, to find out percentage of province, yes, producing more wine. So if you don't just want to find a number or value, but you actually want to find a percentage, then you can, here is actually a bit similar, but a little different. As you can see, again, from the wine reviews table, pull me the province variable, apply the value count function, the head function, and then divide that to get to the length. Actually means it refers to the length, basically refers to the length. Yes, length. And then yes, but wine reviews again. So basically what I'm saying it to do is, yes, what I'm telling it to do is plot a bar chart that tells me in which province, in terms of percentage, which province in terms of percentage produces more wine. If that makes sense, let me know if something doesn't make sense, guys. Oh, let me just see here. Right. Again, you have, wait. Oh, okay, oh, yeah, it's different now. I had made a mistake back to, it's fine. Right, so again, you have bar charts, which can again use for continuous data. Wait, let me just see what that was used for, to find out points received when reviewed. Right, so when the wines basically, or when the review was done of, the wines, scores were, or points were given, points. So what here I want to do is find out what points were given when the wines were reviewed. So for example, I used, again, from the wine reviews dataset, pull me the points variable column and apply to it the value counts, which is basically just counting, and then sort index and plot me a bar chart. So again, your table, your dataset, your variable, your functions, and what you want it to do. So plot a bar chart. And from here, you can just see basically, you can just see like how do we see, in terms of reviews, the points that the wines got. And then that's just basics, but like you can get a bit more techie yourself and like change the codes around and make it a bit more. Yeah. Right. And then you have line charts. Yes. For example, in this case, they've been used to see if the rating range, not even used, if for example, you might have a range, or like your line charts are best, for example, when you have a continuous, for example, data set, and your range, there's quite a long range. So then you can, using a line chart, to be able to visualize that. Right. But in this case, it's not really long, but still I use that. So then you can, that you can use it if your range is very long. So for example, I've used, again, wine reviews, like data set, pull from it, pull the points. Yeah, variable, apply to a value counts, sort index, and then plot a line chart. And from that you can see the most points that the wine scores received. All right. Yes. So the area chart, as I mentioned earlier, it's a bit similar. It's very similar to the line chart. The only difference really is that the area within is shaded in. This then depends on you whether you want just a line or you want a line chart, or you want the line chart with the area shaded in. If you want that, then this is the right plot. And again, very similar. Just at the end, the difference is instead of a line, instead of a line chart, you have area chart. Sorry. Okay. Then histograms, yes, and with a good example. So in this case, used to split data into even intervals, and bars represent range of values, basically. Yes, and in this case, the less than function, or less than, function has been used. Yes, as for example, histograms can have a hard time dealing with skewed data. I think I have an example below. No, okay, I don't have that. Okay, but basically skewed, if I'm right, skewed data, like if let's just say that your price, where did I put? Yeah, let's just say that like your horizontal variable x, a horizontal variable, for example, price has just too many values, and your spread is more on one side, then the histogram will have a hard time showing that to you properly. So the best thing that you will have to do is apply the less than function, so you can just select a smaller range and visualize just what you need, and see a better visualization. if that makes sense. Then another thing with histograms, let me just get the comment out. Yes. Yes. Again, it works best when your distribution is normal. So distribution is normal, meaning it's more towards the middle, so it's not like left skewed or right skewed. So you have even distribution or more, yeah, normal distribution. And again, with the wine reviews, from the wine reviews table, pull the points variable or column, and apply to it a plot and a histogram. All right. And then, yes, you have scatter plots, which are good to see whether there is a correlation between, for example, two variables. Yes. And in this case, I've used like the variables price and points against each other, just to see whether the price of the wines and the points, like in terms of reviews that they've received, when being reviewed that they received, whether these two correlate. And I've also used downsample, downsample like sampling technique or function, because there were just many data points. And as I mentioned earlier, like on the slides, when there's many data points, there's a risk of like overplotting and getting data just everywhere. So I've downsampled to just 100 results. So then that way you get a scatter plot that makes more, just with less points, and that makes more sense and allows you better visualization. And again, from the wine reviews table, wine reviews, like pull the price, downsample that, or sample that, and plot me a scatter plotter, yeah. And then also making clear, you have to make clear, yeah, you have to name what your X variable is going horizontally and what your Y variable is going vertically, so that way you have your visualization at the right place. And then, all right, the hexagon plot, yes, which is used to deal with large numbers and your interval data and points that are then within hexagons. That way it just avoids, how do we say, many data points overlapping each other, basically. Yeah. This has just been a little bug with, I think, prices not showing up, but basically you get the main idea of how it works. And again, from the wine reviews table, pull the price variable, sample that to just 100 results, and then plot, yeah. And again, the hex bin function, which has been explained, like the binning function, which has been explained in last week's session. And then also assigning what your X and Y variable are. And then, yeah, using grid size, yes, in terms of the size that you want it to be. I hope that makes sense. Let me just go on the next one, because I want to give a bit of time to Temitope to present his part. Okay. This is,
Thank you, Farah. So this is the last part, right? The hex plot.
Yeah, there was just one last thing. Just these two here. Just at least want to show them these two, because these are part of the, they might find them important. You have like stack bar charts, and for example in here, yeah, yes. Here the data set is called wine counts. That's why it's named differently. And then to that data set, apply plot and bar chart. So that way you can visualize different variables against each other and see the different scores that they received in terms of, okay. So for example, you can see different wines and the different scores that they've been given. For example, the red blend, Pinot Noir, and other source. That's good when you want to compare anything with scores and smaller numbers and multiple variables. And then you have bivariate line chart. That's just, again, for example, you want to compare different wines and which have been assigned to different lines, which I've just earlier told you that I've done something similar to when in the workplace before. Yeah, which is helpful when you have more than one type of something within a category, basically, that you want to compare against schools. I'll leave it to that and I'll hand it to Tammy. I think he had something to I think about modeling. Let me just maybe stop sharing. Yeah.
Okay, thank you so much, Sarah. So if you have any questions about the visualization, just wait till the end and ask your questions, or you can type it into the comment box so you do not forget. So, Temitope, over to you. Take us through the other half.
Let me just unshare this.
Yeah,
Just being a bit slow.
thank you, Farhan, for the wonderful presentation and the program you've put us through. That's a very wonderful work. Thank you very much. So please, in case you actually hear some strange noises, I'm sorry, they're doing some construction in my house, so sometimes maybe hearing some drilling noises and something like that. Please, I apologize for all those kind of noises, please. So going straight to what I have. One, let me share my screen.
Hello, Temitope. Your baby is cute,
Yeah.
by the way.
Thank you very much. She won't let me put her down, honestly. You won't let me put her down. So I just, okay, let us do the presentation together. Okay, so firstly, is that what? Okay, so let me go straight to one. I would like to have put a comment on what Farhan they actually, in case you are with Farhan notebook and probably want to try and execute the visualization she has done. In case you encounter error, so I want to actually just help a little bit of explanation. If you notice, what she did was to mount it Google Drive. Let me go there. So this is it there. So what I have to do is mount a Google Drive, all right, and then go to this place, and then refer to where it is in a Google Drive, all right. So for example, if you actually shared a notebook and you want to run that, you may run into it because first, you may not have the same directory as our own first, and secondly, the data you will not have it in your own directory. So that's why I've actually created an alternative in case you actually go into error here. So firstly, you don't necessarily have to actually share a Google Drive, because sometimes you want to send a notebook to someone else to look, and then for them to be able to actually use the data is very difficult. So that's why I actually provided some different alternatives, like three alternatives that you can actually import your data into your notebook and be able to share it. So one is this one. So first, you know how to actually get a shareable link from your Google Drive for that. Firstly, you download the data. Probably our farmer will actually show you the site where she actually downloaded the data. All right. So you go to your Google, you download it and upload it on your Google Drive. All right. And then you go to Google Drive. This is data set, for example. Okay. Then you click on this is the data she used. Right click on it and said get link. So when you get the link, all right, just probably copy the link, okay, and then I'll go to that what's it called, the lab that she used, and then you use this first thing here. Look at this thing. This is the most important thing here, okay, that you have to know. Just copy and paste, okay. Then the ID is the link you copied. So this link I copied, if I should enter like this, for example, and I click on the link, okay, you see, if you put this one directly like that, it will not work. All right. All you have to do is just to copy from this place to view. That is the ID that you need. So that's what you copy, okay, and you put at is equal to here, okay. So when you put it there, that's when it will work, and then from there you can actually use the link anywhere. So for example, if I should actually click on this now, for example, I want it. Let me just try and clear my output. So let me go to the place again. Okay, so first the normal library, and I go to this. So this is the place now. So now, if I click on this, for example, now, that is when the data will be able to view, or else you may have difficulty in getting your data, or try to actually use the visualization that you used in so if I should read it now, notice that will come out now. Can you see now? So this is data now. So for example, if you have actually used the what they call it, the mount and everything, you don't use direct. So if you want to use the mount one, okay, all you need to do is to ensure that you have the data in this directory. So now you download the data, you import it into your drive, and then you now go to this directory. Okay, can you see what is saying that? Okay, content drive, my drive, it is in collab notebook in AAIS technical and Richard group data set. So this is the directory of that in my Google Drive. So if this does not correlate with your own Google Drive, the mount may not actually work to get the data out into the notebook. So that's just what I want to say. I've not spent much time, so that's just it. So now going to the major thing now. So this is what I want to talk about. Why is it not showing white down? Let me change it to white background, please, so everybody will be able to see it. Okay. So this is what I want us to work on. AAIS in King College is a task for everybody to work on. All right. So I believe that I can go 1 hour telling you this, telling you that, and still, if you still don't lay hands on it, you'll not be able to actually see get what I'm talking about. And also, there's different way that you can actually run your. For example, if I want to use different ways to actually do our own visualization and everything, which is not actually generic. It's not actually the way everything is like that. You can actually use different method and still get the same answer. So first, there's no one way to actually run your model or write your what do you call it, your Python code. All right, and that is why Stack Overflow is very important to you. Anytime you actually have issue, Stack Overflow is always available. This is what you call Stack Overflow. Just click on go Stack Overflow and go to this place. Anything you think you have issue on, just search here, you see it. Okay, I don't need to cram your code. Right? All you need to understand what they are.
Why you are showing about Stack Overflow is not showing on your screen. I hope you know that.
Okay.
Oh yeah,
So
yeah.
you're sharing just your page. You're not sharing your desktop. So if you're switching screens, people can see what you're showing.
Oh, okay. Let me go there again. Sorry, I don't know that. Sorry. Thank you for that. Let me go down and share again. I thought it's share all everything. Share all, okay, let me just say share the entire screen, right? Okay, all the window. Okay. Okay, so this is Stack Overflow. So there is it now. So anything you want to learn, okay,
Great.
you have issues. So just type it here, okay. You want to how to import data into Python, type it. So one, you don't need to be scared of Python. You don't need to, for example, I can't even remember the code sometimes I've written. Okay. All I just need to do is just type it and confirm it, and that is all. Also, another thing that is also going to be your good friends is GitHub. Maybe one of these days I ask us how to go to GitHub because it's very important. For example, just if you've written a project, all right, there's a place that you can always keep it so that any day, any time you can go back there and have reference to it and see what you can use. This is an example. For example, this is an example of GitHub, okay, whereby you have your repository, okay, where you have different projects written on. All you need to do is just click on it, all right, and then you take you to different projects you've done, and that's all you need. Like I said, for example, now you just like you have your LinkedIn account for professionals or different you've done, or you can write different what they call it articles. GitHub is the articles for any programmer. Okay, you have anything you want to do, you worked on, just go and put it on your GitHub. So any single day you can just go there and reference it. Okay, so that's just the brief thing I want to just introduce you to. So back to this place. So this is what you are working on. I want everybody to work on. It's a task. Okay. And I'm not going to give you any answer concerning it. It's going to be something I have to go on, get your hands dirty, and do whatever you think you can do. All right. So it's about houses in King County, USA. Okay. So these are the columns you have there. Okay. The ID, the date the house was sold, the price of the house, the bedrooms, that's the number of bedrooms, the number of bathrooms, then the square feet of the living room, the square feet of the lot, the floors, the waterfront, waterfront in the apartment, does it have waterfront, the view, the condition, all right, the basement. So these are the attributes that this data has, all right. So now, what you want to know is to be able to predict, okay, what is going to be the prediction if, for example, what's going to be the cost of a 3-bedroom apartment, all right? compared to a 2-bedroom apartment. Okay, so and again, you're able to find out, okay, does actually bathroom actually affect the price of house sales? Does having a waterfront actually affect the price you're going to sell a house? So those are the things that you're going to be using this modeling to do. Okay, so now, firstly, these are the important things you need to have to be able to execute this. Okay, so import panel, I think Farhan has made mention of that. So panel is just the data frame whereby easy for you to just have your data in a well formatted tables. Okay, so that's just it. A matplotlib is just for visualization. And when you see this matplotlib as PLT, just means that instead of you calling matplotlib.pyplot, you call it as PLT. Okay, short form. NumPy as NP, that's short form of NumPy. Okay, Seaborn as SNS, just short form of Seaborn. So these are these. Like I said, I can't explain everything to you. Okay, all you need to do is just go and read more on it. All right. So this is like defining a program. All right, for visualization. Okay, so like this, just leave it like that, just enter and run it. So now this is it. So this first module, okay, import your data set. All right, the file name is there already. All you need to do is to one. Let me just click first of all one it for so I can see it. I want the first one. Just control and enter. Okay, this one to control and enter. All right, this one to control and enter. Okay, so for you to have to load the CSV file, then df.air, just want to see the top 5 or top 10 of the data. So this is top 5 of the data. Go to see how everything is. So you can see the ID, the date, the price, the bedrooms, the bathrooms, the yards, the square feet, living room, everything all there. So now each task asks a question, and this is for you to answer. Okay, so this notebook you are seeing is not, the project is not written by me. Okay, it's one of the courses I did, but the answers were written by me. All right, so one of the answers I submitted. So, but I hid the answers so that you can write your own. All right. So the question is actually, they say display the data types of each column using the attribute D type. All right. So what they ask you is actually using D type to actually get the data types. Okay. For example, if I put df dot D types, D type. So this should be dot instead of comma. So sometimes. Let me see df.ed. Let me see if I've actually imported the right thing. Okay, so sometimes it can just show you some errors, but don't worry. It's the types. So let me just put this bracket. What should be? This data frame has no attribute D type. Hold on, please. Okay, it's meant to be types. Okay, yeah. So it's made of type. It's meant to be types. So this is it. Okay. So now, it's going to give you different types of the columns. For example, the ID is integer 64, date is object, and so on. So it gives you different attributes just for you to understand your data. All right. So this is what I've written here, that for you to be able to see, in case you don't get the answer, all right, all you need to do is just click on this to give you the answers. So the code is hidden so that when you are writing your own, okay, and want to refer to it, okay, let me just finish it. So for example, want to get it this type and you don't know how to do it, just click on this, okay, to show you the answer, and then you can run it in your own cell. Okay, and that one says we use the method describe to obtain a statistical summary of the data set. So we want to use describe to see the statistical summary. Okay, so just a df dot describe dot describe.
Still write comma, not dot.
Yeah, don't mind this describe. Okay. So can you see now? So showing describing your whole data. All right. Okay, so can you see now? So this is just like statistical summary, okay, in terms of count, mean, media, state, and everything. Like I said, if you didn't get it, okay, you can actually click on here, okay, click to view the solution, and you see the solution here. All right, so just to let you know how it's going to be. Okay, so you are then meant to actually go down and run it. So that's just the task, right? Because I believe that you can get yourself a hand dirty, it's better for you. And if you have issues, then you can come to the what they call it, the section on Slack. Then we can actually help you out with this. So now this is now the major thing now, just to put you to the model development. So model development is basically like trying to make a prediction, okay, on data set. Okay, so the most popular one is either linear regression or multiple linear regression, which is the most popular one. All right, and I don't know if you've all done something like this linear graph where you have your intercept, you have your slope, y is equal to intercept plus slope plus x. So that is basically what we call linear regression. Okay, so now let me forget the data out. So now, so this is what I'm talking about. So we did this in the last semester on our business analytics, where they explained to us what a linear model is. So just for you to know that, okay, there's going to be a predictor, which is the independent variable x, and the response, which is dependent variable. So y is the response and x is the what? The predictor. So meaning that, yeah, meaning that this y hat is the what do you call it? The prediction, all right? So A is the intercept, B is the slope, and X is the what? Is the predictor. Is the predictor. Y hat is the prediction. Okay, don't confuse them together. Let us say Y is equal to, let us say, okay, for price, for example, okay, price of a house. Okay, let me just use that one for example. Okay, let's just say 3-bedroom. Okay, the price is £10,000. Okay. 3-bedroom, the price is £10,000. So you can ask, okay, then how much would 2-bedroom cost? So now that's the prediction of how much the 2-bedroom cost is what we call y hat. All right, and this is the equation that will help you to predict the value of y hat. Are you getting it now? I believe if the scenario I use actually makes sense. Okay, so y hat, so don't confuse them together. Y is just normal response. Okay, for example, the price of a house, if it is 3-bedroom, then if it's 2-bedroom, you should don't have any idea what it's going to be. How do you know? It's by using a model to predict it, and the prediction is called y hat. All right, so now this A is intercept, this B is slope. All right, so you don't need to know the mathematics. Okay, that is why in Python is it's an open source open source programming language, whereby there are a lot of people that are contributing to it. Okay, whereby they make it very easy for you to do. Okay, so let us try and do a linear model. Okay, first, for you to actually do a linear model, you have to actually import it from skylearn.linear model. You've already imported it already from the first page here. Where is it? Okay, so this is how you do from skylearn.linear model, import linear regression. That's how you import it. Okay, because linear regression is in this. You can actually say import skylearn.linear model, in which linear regression is there, but you don't want to actually import all the resources. For example, on this sky.linear model, there is multiple regression, there is polynomial regression, there are different modeling there. So for you to just import the only thing you need, that's why you use from skylearn sklearn.linear model, import linear regression. Meaning that all you want in that place is just linear regression and not everything that is there. So if you want to do maybe a polynomial regression, you say, okay, from sklearn.linear model, import polynomial regression. So that's how it works. Meaning that from this modeling something, okay, so this thing, for example, it is coded. There's some people that what they call it, the open source people, that the programmer have already done this already. They have already put different models into this thing. All you need to do is just import it and use it. Okay, so this is it now. So I want this, all right. So then so you cannot actually assign a variable for this thing. So I can either use using linear regression, or you can just assign it to this variable LM. Okay, so I click enter now. So already shows that, okay, you have assigned a linear regression to LM. Meaning that whatever you're going to be doing, you're going to be using linear LM. So by the way, this data is about vehicle, okay, prediction of car, okay. So this is just basically this about this data different from the house. And that one of house prices is a task that we're going to do on our own. But this is just an example of how to actually run some models or some models to use on that task. So for example, now, this kind of car, the attributes, these are the attributes. The attributes have normalized losses, symbolic aspiration, number of doors, body style, drives, wheels, edge location, okay? Different columns, different attributes. So when you see column, they call it attributes, all right? So different attributes, and these are the prices, okay? So for example, you have a horsepower of 111, compression of 9, stroke of 2.68. What is the price? The price is this. So now, we now have compensation of 10, horsepower of 200. What is going to be the price? And that is why the depiction has to come into places. Okay, because look at the historical data, okay, you can use it to predict, okay, a new data set entirely that is not in this category. All right, so that's why we need to do our prediction. So now here there is only one predictor. Like I said, when it comes to linear regression, you only use only one predictor. Okay, you're only using one predictor. Okay, when it comes to linear regression, when it is multiple linear regression, you have more than one prediction. Okay, so here they're using highway miles per gallon. Okay, that's what they're using as the predictor here. And then what they're trying to predict, which is the response, is the price. Okay, want to know what is the influence of this highway miles per gallons with price. Are they really correlated? Okay, can you use it to predict the price of a car? Okay, and that is why we are talking about linear model. Like I said, linear regression, which is only one predictor. So now, first you have to fit the data. Okay, you fit the data to the data set. Okay, for example, it's like, okay, for maybe 80 miles per gallon attribute, the price is £10,000. For 100 miles per gallons, the price is £20,000. So you're not trying to fit that linear model into this data attribute, okay? Because now we are using, so this is the predictor, and this one is the target. So this target to actually, we are using this model to fit the predictor and the target, so that you'll be able to predict any other values that you don't even know about. For example, let us say for highway mile per gallon of maybe 150, what is going to be the price? Okay, so that is why we're using historical data to understand the data, okay, and see if we can actually get the actual price. All right, so now when you do that, okay, it gives us this. Okay, so now this y-hat now is the predicted value. Okay, and this y is giving us this value, which means that if you look at this, for example, okay, let me click on this. So this is going to be the intercept for you to do the intercept. No, you remember that we said when it comes to linear model, it is a plus bx. It means that a is intercept, b is the slope. So now this is intercept, okay, and L coefficient is the slope. So now, if you now want to actually predict another value, all you need to do is, what is a? A is 3842.3. What is b? B is 821 minus 821. Now, if you say no, x is the predictor, it's okay. We have maybe a miles per gallon of 150. What is going to be the predicted value? That will now put 150 times the coefficient, which is minus 821, plus what is a? 3842, and that's why you get your predicted value. Okay, so that's just basically of a linear model. Just to give you a brief thing about that. So that's just so. And so this notebook is something I can actually share, because like I said, it's not everything I can actually teach you, but with this explanatory notebook, you can actually be learning step by step of what do they mean. If you have any challenges, then you can let. But the major task is to actually be able to execute the house-rent project. So I won't waste too much of your time. So now let me just one single model. So let's just look at this plot. Okay, now look at this plot. So this plot is telling you that this blue one you are seeing here, okay, this blue one you are seeing here is the predicted value. This plot you are seeing here is the actual value. It means that the predicted value does not really fit this actual value. notice they are not actually close to each other. Okay, which means that okay, when it comes to miles per gallon of a car, it cannot majorly predict the value of the part of a car. That's what it means. So let me just go to what I want to show you again so that you can. So for example, look at what I said now. See, look at this for example. Okay. Oh, sorry, I think it's not showing again. So I don't know why it's not. Don't worry. So it's not showing that the memorization slide. So don't worry anyway. So sometimes we see another one that, okay, let me see if I can quickly another one that can actually fit more better. Oh, I think I didn't put it there. Let me just try and show you what I'm talking about. Okay, I'm almost done already. So I want to show you this presentation here. Okay, so look at this for example. This is what we did the other time. This is actually what is fitted when you use miles per gallon as an attribute to predict the price of a car. Okay, see what it is. It means it doesn't really fit it. Now look at this one for example. Okay, look at this value. Probably this value is probably the number of doors of that car. Okay, and guys, this one fits more better than this. Okay, and therefore, if you want to see the score between this and you notice that this one you get a better house score than this because it properly fits this line than this. Okay, so that's how you actually try to see the best model that can. For example, you can try linear model. I give you this. You can try a multiple linear model and we give you this. You can try a polynomial model that will give you more closer, more fitted diagram like this. So that's why you know, okay, this model is best fitted for my prediction. That just so by the time you look at that example, what's call it, notebook, okay, there are different models that they can use it to actually analyze the whole thing. So that's just for me. So I won't keep people too much here. So thank you. So if you have any questions.
Thank you so much, Temitope and Farah, for that very insightful session. We know we have gone over time, but we just want to ask if anybody has a question for the next 5 minutes. If you have a question, you could just ask, and either on visualization or on the data on Python codes.
Yeah, hello, good evening, Reta.
Good evening.
Okay, how do we access the recordings of this session, please?
Okay, so we usually share the recording on the WhatsApp group after the meeting, so you can access it, and then we'll send the slides as well, so you can look at it as well in your free time. However, I would encourage everyone to please try out. Farah will send the data set as well, so I would encourage everyone to please try out what you have been taught today. And if you have any challenges, if you have any issues with the coding, like Temitope said, you can just check Stack Overflow. And if you do not get a solution, then you can reach out. I think Temitope said he will send the file for the codes that he ran. So you could just use that to practice as well. But I would encourage you try it out yourself before using that script. So is there any other question?
Does that same apply for previous session like that of last week, which Hussein took?
All the recorded sections are in the WhatsApp group.
Okay, thank you very much.
You're welcome. Do you have any other question?
Please, Henrietta, please, how do I get the data set that Temitope used for your section?
So we will send it on the WhatsApp group tomorrow or next.
All right, thanks.
Okay, like the one I from a notebook you don't need to.
Okay, let me answer this. All the slides and all the you've seen all the code and all the data set links you will be given in the slides that we send for every session. So if you see in every session, there is a link on each slide. So you will see all of it there.
Yes, another thing is this is also supposed to be officially our last teaching sessions. So after this session we're going to share people into, we'll have one more session where we'll explain the platform we're going to be using for our learning, and after which we're going to divide people into groups, and they are going to work on different projects. So whatever your interests are, we'll send out a survey for everyone to fill. So whatever your interests are, what you want to learn, you will have to fill it in the survey. If it's Tableau, if it's machine learning, if it's data analytics, that way we'll be able to group people into groups, and then we can take it up from there. Is there anything anyone else would like to add? Hussein, Chidima, Farah, Temitope?
Yeah, all I need to say is that from the notebook I actually shared, I'm going to share, it's only contain the links already. So all you need to do is just to press enter. You connect to the online source, and that will be all.
Okay, thank you so much, Temitope. Thank you everyone for taking time out to be here. I hope you have learned one or two things that would
Very
make
well.
you a better data analyst. And please try to practice what you have learned. Otherwise, the work being done by all of these beautiful ladies and gentlemen here will be for naught. So let's understand, or let's know that people are actually practicalizing what they're learning and gaining these experiences that you will need in the job market. Thank you for today's session. Do have a lovely weekend.
Please add me to the WhatsApp group.
Okay, Tochukwu.
Yeah.
So
Whoever
your challenge is
received
quite
the
different, because I was looking for you on the registered members list and I couldn't find your name there. So what we'll do is meet me tomorrow at room 101 in Richmond, so we can sort it out.
Time.
Okay, so I'm going to be there from 12. So anytime from 12 to 5.
Okay. All right.
Thank you.
All right. Thank you very much.
Thank you, everyone.
If we don't have any
Thank
other
you.
questions, good night,
Thank you
everyone.
so much. Good night.